basic communication principles, and in this film we will study some communication basics. And first of all, let's see what serial and parallel communication, what they have in common and what the difference is. Serial communication is when you have one line between the sender and the receiver, and like this. And parallel, you have multiple lines between the sender and the receiver. So this is the sender and this is the receiver, sender, receiver. You would maybe immediately think that the parallel communication is much faster than the serial, but the problem is that when the data communication rate goes up, when the speed goes up, you have really big problems with synchronization, because the bits here that are sent simultaneously will not be received simultaneously, so they will maybe spread like this. And you have serious timing issues or synchronization issues with faster communication. So therefore, for most systems, serial communication is actually faster. So for example, my communication on my computer, I have something called USB, and the S in USB is serial. So USB is serial communication. Also on my computer, between the motherboard and the hard disk, I have something called SATA, where the S is serial communication. So even between the disk and the motherboard, the communication is serial. However, between the microchip, the main brain of the computer, and the memory chip, the communication is parallel. So it's parallel because you have a fixed route for the data. The data is on a motherboard, follows pre-printed lines, so you know the exact distance between the sender and the receiver, which in this case is the microprocessor and the memory. And you also know that the return path, it follows the same way, so you can actually control the delay problems or the timing or the synchronization problems. But as I said, the cables here are fixed on the motherboard, the printed motherboard, while in the USB and the serial ATA case that I had here, the communication is on a flexible cable. So you can bend and twist the cable, which will change the properties of the cable, so that would seriously influence the synchronization problem. So therefore, for slower communication, which still is very, very, very fast, you tend to use serial communication, while on-board printed circuit communication tend to be parallel. Simplex and duplex. They are terms that are frequently used in communication purposes. Duplex is when you can send data from the sender to the receiver and back again. So they can both send. So this can be sender, this can be receiver, or this can be a sender and this can be a receiver. That's when you have duplex. Full duplex is when they can both transmit and receive at the same time. So for example, when I talk in my cell phone, I have full duplex because I can talk while the one I'm talking to can talk simultaneously. So we can double communicate. While for example a walkie-talkie is so-called half duplex. One talks and then the minute later the response comes. So you can only communicate one way at a time. That's called half duplex. Simplex is, for example, broadcast, where you communicate one way only. There are, however, other definitions like ITU, the International Telecommunications Union, the, for example, half duplex term is sometimes used when you communicate one way only.